is rational functions number 1, where we are simplifying, adding, subtracting, multiplying, dividing, and stating excluded values. Okay. So just a reminder of what an excluded in our rational functions are things that make the denominator equal to 0. So we always want to look and we want to say, once we simplify it, we're going to say x can't be this or x can't be that. So it's part of our domain as well. So the excluded values it's what makes the denominator equal to 0. And even if something gets canceled, if it was ever part of the denominator, you still want to include it in your excluded values. Okay. So when we simplify our rational functions, we're going to start out with just some monomials. We'll get to some later that we have to factor first, and then we start to cancel things out. But this was just, I wanted to do a little review for monomials before we get going into some other ones. So if you look at things when you just have numbers and you've got variables, remember we just simplify the numbers in the front, right? What do 28 and 16 both have in them that we can divide by? We're going to divide by a 4 for both of those, right? So this would be a 7 and this would be a 4, right? Because we divided both those by 4. And then I've got 3 x's on top and 4 x's on bottom. So how many are going to cancel out? 3 will cancel out, and how many will be left? 1, and is it on the top or the bottom? It is on the bottom, okay? So that is our simplified answer. So we simplified it, but we still need to state our excluded value. So we look back at our original problem. What value for x would make this denominator equal to 0? What would we plug in there to make it equal to 0? 16 times what is 0? 16 times 0, right? So remember, if we don't have any like addition or subtraction and then we just have the variable x, our x cannot equal 0. That's what we're going to say here. Because if I plug 0 in for x, 0 would be in the denominator. This is my excluded value. All right, y'all try number 2 real quick on your page. So let's look at the 40 and the 10. 40 and 10, that actually divides evenly, so that's just going to be 4, right? 40 divided by 10 is 4. Then we've got 4 r's on top, 2 on the bottom. So how many are canceling? 2 are canceling. There'll be 2 left on the top. So 4r squared is our answer. There's nothing left in the denominator, okay? But we always look at the original denominator and what can r not equal? Because it would turn it into 0 on the bottom. It cannot equal 0. Because 10 times 0 squared is 0. And remember, zeros in the denominator are undefined. So those are our monomials. That's a review. We did that earlier in the year. Now we'll look at some that have binomials or trinomials, and we have to factor those first. So if you see a problem like this, we can't just start canceling stuff out because of the plus signs. So what we have to do is we've got to factor the top, factor the bottom, and then see if there are things that can cancel after that. So let's look at our numerator. What can come out of both of these terms? Bigger than a 2, a 4 and an x, right? So we're going to pull 4x to the front here. And then you're left with x plus 2. What comes out of both terms in the denominator? An 8 and an x. And you're left with x plus 2. Before we do our canceling, let's go ahead and write our excluded values down so that we don't forget to write them down. If I look at 8x here in the front, what can x not equal for this first part? X cannot equal, what would make 8x equal to 0? It would be 0, right? Because 8 times 0 is 0. So for our first part, x cannot be 0. And our second part would be in the x plus 2. What would make that equal to 0? -2, right? -2 plus 2 is 0. So it's just the same thing as if we're finding zeros or roots, like in polynomials. So everything that we just did, just think of that. Oh, if that's a polynomial, I know 0 is a root and -2 is a root as well. So x cannot equal -2. All right. So now we see some stuff that we can cancel out. I've got an entire x plus 2 on top and on bottom. So those can go away. I have a single x on top and bottom that's not added or subtracted to anything, so those can go away. And what is 4 divided by 8? How does that simplify? 1/2. So this is just 1/2 for our answer. All right, let's try one that has a quadratic in it, just as a reminder for this. So there's not a term that's in all three of these. So we have to see what multiplies to 63 and adds to 16. Anybody think they got that? 9 and 7. Yep. So this is going to be, I'm going to do it on the top because I need some space for this. R plus 9 and R plus 7. Is there something in every term on the bottom? An R, right? I need to pull this R to the front before I can factor the quadratic. Okay, now I'm going to write it in the fraction, but I knew that I'd have to take that out first. And what multiplies to 81 and adds to 18? 9 and 9, okay. Oops, I forgot the R plus. So let's go ahead and do our excluded values before we cancel. We always do that before we cancel out. So it looks like if we look in the denominator, your excluded values are, what's our first one? -9 is one of them. Our first one is 0, and then -9, and then -9 again, but we only have to write it one time. So x cannot equal 0, x cannot equal -9. Okay. All right, and then you look and things can cancel if you have one on the top and one on the bottom. Is there something that can cancel in this fraction? Yes, the r plus 9s. You can do 1 for 1. So on the top is r plus 7. On the bottom is r times r plus 9. So that would be our answer. I do want you to notice, and people do this every year, and I just want you to think, oh, no, that's not even possible. Some people go, oh, there's an R and there's an R, and I'm going to get rid of them. You can't if you have things that are added or subtracted next to it. Like this is a grouping, and the only way to get rid of an R plus 9 is another R plus 9. This R plus 7 is a grouping. The only way to get rid of an R plus 7 is another R plus 7. So you can't just cancel R's out just willy-nilly. Okay. The reason we could do the X's here is because they stood alone in the front without any pluses or minuses. So any questions on simplifying our fractions?
Each equation is going to be x cannot equal 0.
If you pull that variable to the front, we'll have some in a minute that won't have it not equal 0.
Okay.
If the denominator just said x minus 2 and that was all, it would just be 2. Just all of those, we had x's in the front. All right, so those are the simplifying ones. Now we are going to do some that we add or not add or subtract, that we multiply or divide. With multiplying, it's just kind of like Now we have two fractions that are next to each other. We do the exact same thing. You pretty much just extend your fraction bar out a little bit. So we can still cancel diagonal, cancel up and down. But we still factor everything we can factor first. But we just have 4 parts to factor instead of 2. I mean, it could be. Can I factor 10? Is there anything to do with that 10? No. All right, let's look here. We've got 18 and 27. Is there something in common with 18 and 27? Yep, 9. 3 also goes into it, but 9's the bigger one. So let's pull a 9 to the front. And that's 2 minus 3p. And then over here, what comes out of 30 and 20? 10, okay. 10, and that is 3p minus 2. So let's see right now. Let's go ahead and do our excluded value, and then we can see what we can cancel out. So if I look at my denominator, I have a 9, I have 2 minus 3p, and I have a 10. So 0 is not going to be one of our excluded values on this because I don't just have a single p sitting out in the front. So what I'm going to do to figure it out is set this 2 minus 3p equal to 0 and solve it. So subtract the 2 and divide by 3, and p cannot equal 2/3. Okay. All right, does anybody see something that can cancel? I'll write this a little bit clearer over here. So we've got 10, another 10, a 3p minus 2, a 9, a 2 minus 3p, and a 10. Do we see something that can cancel out for sure? Is there a number that's the same? Good, we can get rid of our 10. 110 and 110. You can't do 2 for 1, it's just 1 for 1. And then now, I don't know if you've ever realized this or noticed this, but if you have the same numbers and they're just reversed, but they're both difference, they're both subtracted. If you divide these by each other, you're just going to get -1 for your answer. That's because I could switch this order up. I can change this to -3p plus 2. I'm going to switch the order. And if I pull a negative to the front of that, if I take a negative out of both of those, it is the negative of 3p minus 2. So if I have something like x minus y and y minus x, you can cancel them, but when you cancel them, you leave a -1 in that spot because they're just the negative of each other, of the signs. So if you've got the same numbers and it's a difference, we're going to cancel it out, but we leave a negative in the front of the problem. Okay, because it's like I rewrote this, but there's a negative that's going to pop in the front. So I'm going to cancel, but I need to put a negative. That's why I have the negative there. So if you ever see that, you can just think, oh, those cancel, but I have to have a negative. So our answer, the only thing that's left, this one's getting kind of messy, is -10 over 9. So I rewrote this one just to see what it looked like, rewrote the order, and then I factored a negative out to the front. All right, I want y'all to try number 6. Try number 6 and see how that. So let's see if you were close. All right, what comes out of our first set in the top left? What comes out of both of those numbers? A 5. So let's go ahead and pull our 5 to the front, and then you have x plus 3. This is a quadratic, right? So what multiplies to 30 and adds to 7? 10 and 3. So x minus 10 x plus 3. Sometimes when I'm doing these problems, once I've factored something, I like to scratch it out so I know that now these are the things that I'm left with on top. These are the things I'm left with on the bottom. Let's go ahead and write our excluded values before we cancel. So x cannot equal, what's our first one? X cannot be
positive 10.
It can't be positive 10. It can't be
Negative 3.
And there's not a 0 on this one because there's not a standalone x. Okay. All right, and now let's see what's going to go away. I've got a 5 up top. Is there a 5 on bottom? Yep, see ya. I've got x plus 3 on top. Is there an x plus 3 on the bottom? Yep. I've got x minus 6 on top. Is there an x minus 6 on the bottom? No. So I need to leave x minus 6 and x minus 10. I cannot simplify that any further. X minus 6 is a group. It's stuck together. X minus 10 is a group, and it's stuck together. I can't split those apart. All right, so those were our multiplying problems. Now we're going to divide. Do you guys remember how to divide a fraction? What do you do when you're dividing a fraction? You flip the second fraction and then you multiply across. Okay. So our next kind, we are dividing. So just as a reminder, when you divide, you flip the second fraction and multiply across. So this second fraction was 5 over x plus 10. I'm just going to scratch it out and flip it over right here just so I don't have to rewrite the whole problem. So I'm going to put the x plus 10 on top and the 5 on the bottom. And now it becomes a times problem. What can we pull out of both of the numbers on the top? An x and a 2. So I'm going to pull 2x to the front. And that's 6x minus x. No, 6 minus x, sorry. Erase. Okay. And then we're going to factor this denominator. What multiplies to 60 and can get us to 4? And 6. Good. So x plus 10, x minus 6. Before we cancel, we'll do our excluded values. One weird thing with division problems for your excluded values, you count it as an excluded value if it was ever in the denominator. So we also have to include things that are up here because at the beginning of our problem, it was in the denominator. So when you're doing excluded values for division problems, you have to look in the denominator here, and also in that numerator. So I'm going to draw a little L shape that helps me remember it, like this. I mean, it's kind of an L shape. But for division for excluded values, you do the bottom here, and also the top. Okay. So we're checking here, here, and here. It says check for excluded values in those 3 positions when you are doing division problems, because that was at one time in the denominator. All right, so let's see what our excluded values are. What's our first one? X cannot equal negative 10. and then it cannot equal positive 6. The 5 is just a 5, so that doesn't do anything. There's no variable. And we already got the negative 10. So x cannot equal negative 10 or positive 6. Okay. All right. I have a 2x. There's not a 2 or standalone x on the bottom, so I can't do anything with that. I have a 6 minus x. Do I have a 6 minus x on the bottom? I have an x minus 6, so we can cancel those two out, but when we cancel them out, what do we need to have? We need to have a negative. So when those go away, since they're reverse of each other, I'm going to have to insert a negative in the front. And then I've got x plus 10. Is there another x plus 10? You betcha. So we cross that one out. And it looks like we're left with negative 2x on top and a 5 on the bottom. All right. You think y'all are okay with division? Do we need to do number 8? You just got to swap these, factor them, and multiply. So I'm going to skip number 8 so that we can get on to the addition, subtraction, and compound fractions. All right. When you add and subtract fractions, you have to have a common denominator. So that's our important thing about addition and subtraction. So we must have a common denominator. And just like a regular fraction, if I said 2/3 plus 7/3, 2/3 plus 7/3 makes how many thirds? 9/3. We don't change the denominator. Once it's the same, we keep the denominator the same and we just add across the top. So just remember that. That rule with fractions applies also when you've got variables in them. Okay? So let's check out. Y'all might not have this problem written down. I'll give you a second. That was one of the last ones I scrolled to. All right, on our first problem here, do our denominators match? Are they the same? Yes, they're the same. So I'm going to go ahead and write down what my denominator is going to be because I know it's 5b squared plus 10b. And then just like I did before, 2 plus 7, that's 9. I'm just going to add together the things that are in the original numerators. So I've got b minus 6 plus b minus 4. And we're going to combine our like terms. So that makes 2b minus 10 over 5b squared plus 10b. On these problems, I'm not going to have y'all simplify further than this. Occasionally, you might have like a variable or a number that could come out of everything, but the ones that I'm going to give you shouldn't have anything like that. If you end up with additional problems on CUDA because you're getting some wrong, you might have some that you've got to cancel out, but I don't think I gave you any in your assignment like that. And I'm also not going to ask for excluded values on addition and subtraction problems because there's enough already that you have to do on those. But we could find them by factoring if we wanted. But everybody okay on this addition problem? These are the ones I like the most when they're already the same denominator. So let's check out number 10. Are the denominators the same? Yep, so I'm going to go ahead and write that denominator down. I know that's what I'm sticking with. And I'm going to write my numerator. I always put parentheses around the stuff that's coming in the second numerator because the negative is going to apply to both of those. That's where I see the most mistakes. And it's always an option for multiple choice for if people didn't go ahead and distribute this negative. So this is really negative x and a plus 3. So 4x minus x is 3x, and negative 5 plus 3 is negative 2. If you want to rewrite it, you can. 4x minus 5 minus x plus 3, if that helps you out. Questions on addition when the denominators are already the same? When subtraction, we good? Thumbs up. Okay. All right. Sometimes our denominators are not the same, so we have to kind of recall what we do in regular fraction problems. So if you think about how that goes, this is going to help you out. If I had 2/3 plus 4/5, I first have to have a common denominator, right? What's my common denominator between 3 and 5? It's 15, okay? There were no factors in common with 3 or 5. So if you don't have any factors in common, to get the denominator, you just multiply them together, all right? Then we always think, I've got to turn this 3 into a 15. So what do I need to multiply this first fraction by to get that 3 to turn into a 15? It's got to be 5. So I've got to do 5. Oh, I need to do the thin one. 5 on top and bottom. Okay, so that's going to be a 10. And then this side's going to need a 3 to get it to 15. So times 3 times 3. And that side's going to be a 12. Then you get 22 over 15. But what I want you to notice is when you don't have any factors in common, we are multiplying this left-hand side by whatever your denominator was over there, right? The 5 on top and bottom. And the other side by the 3 on the top and bottom if you don't have anything that's in common. So that same process applies to ones that have variables in them. Okay. So do r plus 5 and r minus 3 have any factors in common? Like, could I split those up into factors in any way? No, that's as far as you can go if you're factoring it for a polynomial. So our denominator, since they don't have anything in common, our denominator is just going to be the two of them smushed together. And by smush, I mean multiply. So just like this, 3 and 5 didn't have any commonality, so 15 was our denominator. We got it by multiplying it. These didn't have anything in common, so our denominator is just going to be their product. Okay? So now let's think about what does the left-hand side need? It has the r plus 5. What does it need to make it this denominator? Yeah, it needs the r minus 3. So it already has the r plus 5. It needs the r minus 3. So we've got r minus 3 that we have to multiply by on top and bottom. So I'm just going to write 2r, r minus 3. I'm going to simplify in a minute. So I have my 2r. I need to multiply it by r minus 3. Keeping my minus sign. What did my other side need? The r plus 5. Now that denominator matches what we wanted. So I'm going to have 2 times r plus 5. Thumbs up if this is okay, if we're okay. Thumbs up. Thumbs medium if we're kind of Okay. All right, so just another reminder, our denominators didn't have anything in common, so we multiplied them together. Then we looked and said, oh, that had r plus 5, but I needed r minus 3, so I've got to do that on top and bottom. So the 2r has got to be multiplied by the r minus 3. Over here, I needed r plus 5, so the 2 has got to be multiplied by the r plus 5. And now we just distribute and combine like terms. We'll be good to go on this problem. So 2r squared minus 6r minus 2r minus 10. And let's go ahead and FOIL our denominator. R squared minus 3r plus 5r minus 15. And there you go. Everybody all right distributing, combining like terms? We good? Okay. All right, on this next problem, I wanted to show you this one because sometimes you can simplify stuff before you start doing your addition. So just like if you had a problem, you don't have to write this down, but if you had a problem like 3 over 6 plus 4 over 5, you wouldn't leave it 3 over 6 because you would end up having to simplify later on. What would you change 3 over 6 to? You would change it to a half, and then it makes it easier to do the problem. Your numbers aren't as large. Same thing with problems like this. If we're looking at it, we've got 2n or 4n over 2n. What's going to happen with these n's? The n's are going to cancel out, and 4 over 2 is just 2. Okay, and then if I look at all of these terms, every single one of these terms has a what in it that we can simplify? They all have a 3 in it. So I'm going to divide all of these terms by a 3. If every single thing has got a number in it in your fraction, you can just divide that out of all of them. So that's going to be a 2. This will be a 3n plus, squared plus n. Did I put a 3 there when there should be a 2? I'm sorry about that, guys. That's a dotted line tool. Do it again. All right. Do you guys remember how to add a fraction and a whole number? No. Okay. So let's just go back to regular numbers again. Let's say we had 2. We'll do a simplified version. 2 minus 2 over 5. So what you want to do is you want to have a common denominator. What is the only denominator that we have? It's going to be 5. So our denominator is going to be 5. Okay. What helps us out is to go ahead and put this over 1. So if I want 5 to be my denominator, right now my denominator is 1. What do I need to multiply the 1 by to get 5 to be the denominator? I'm going to have to multiply by 5 on top and bottom. Then 2 times 5 minus 2, because I don't have to change that one, and that's going to give us 8 over 5. So we're going to do the same thing. If you have a whole number here, let's go ahead and put it over 1. Our denominator is 2n squared plus n. That's the only one we have, so that's going to have to be our common denominator. So over on our left-hand side, that's what gets multiplied. 2n squared plus n. So 2 times 2n squared plus n. And then this one already had the denominator I wanted, so I didn't have to do anything to it. I just brought the minus 2. I think I'm going to run out of space for this problem, but you can go ahead and distribute, and that's 4n squared plus 2n minus 2. I guess I'll write it down here. And here are our last two. When you have these complex fractions, that's what they're called, we're going to treat them as two separate problems, and then we'll divide them, okay? Because if we have a fraction over a fraction, then we can flip the second, multiply, get our answer. But we've got a sum of fractions on the top, so we need to make that one fraction first, and then we'll be able to flip and multiply. So the bottom is already good. It's already a single fraction. So that's fine for us. We don't have to do anything right now. We'll treat that in a second. So it's already one fraction. We've got to turn this into one fraction now. Okay, so I rewrote that down here. So I need a common denominator. Is there anything in common with x minus 4 and 4 in terms of factors that we could split it up? No. So our common denominator is just going to be the two of them multiplied together. So 4 times x minus 4 is our denominator. What is the left-hand side missing from this to make the denominators match? What do I need? I need the 4, okay. So it'll be 4 times x plus 2. What is the right-hand side missing to make the denominators match? The x minus 4. So I've got x plus 2 times x minus 4 here. I'm going to combine all my like terms and stuff. I'm not going to multiply the denominator out because it's going to help me cancel things out on top in a minute. And all my foiling. So 4x plus 8 plus x squared minus 4x plus 2x minus 8. What cancels out? My 8's cancel out. My 4x's cancel out. It's just x squared plus 2x. Okay. So we took these two fractions, we made them into one fraction. So when you have two, a lot of times you got to make it one fraction. And now we have to divide by what was in our denominator. Our denominator was x plus 2 over x minus 4. We want to divide by that. And remember, when we divide, we flip it and we multiply. So now from the top, we'll multiply by x minus 4 over x plus 2. We had to flip it and multiply, so we're going to flip. That's how we got it in that way, just if you were wanting to look at your notes later on and see where it came from. Is everything factored and ready to go, or do we need to do a tiny bit of factoring? A tiny bit right here? Yeah. What's in these two that can be pulled to the front? An x. Okay. So that's got an x, and then it'll be x plus 2. Now we can cancel. I have a single x. Is there another single x? Nope. I have x plus 2. Is there an x plus 2 on the bottom? Yep. At x plus 4, is there x or x minus 4 and x minus 4? Those are gone. And what is left is x over 4. So when you have those crazy ones, it's just kind of putting all the stuff together. First do an addition problem, and then you have a divide that you'll flip and multiply. I'm not going to write the steps out for the very last problem, but I will kind of walk you through it. For our very last one, we need a single fraction on the bottom, and the common denominator is going to be 16x squared. So you need x squared on this side, 16 on this side. Once those are combined, then it'll be 2x times whatever that is flipped over. You'll be able to simplify from there. Okay, so it's just putting together dividing, multiplying, and addition. We did a lot of work, huh?